Um, Thank you all for making the time to be here. I think after this is lunch, if I'm not mistaken. So I'm probably the person that's standing in between you and lunch, if I'm not mistaken. But I'm going to keep it nice, exciting, engaging. So hopefully this will be a good, interactive conversation that we're going to have. So just a quick one about the talk in itself. So title of the talk, trapped in the AI error loops, right? So I'll get into what that's all about, but I think most of us have probably encountered this type of problem before. Cool. And then just a quick one on who I am. So I'm Omphile Matheolane, all the way from South Africa, and decided to come here and give this talk today. But just a quick brief on who I am. So I'm basically a software developer by heart. Right now I'm more in the technical lead space, but I work within the financial sector within South Africa. And basically my day-to-day job, if I may say, is ensuring developer efficiencies and ensuring that as developers you're able to deliver as quick as possible, right? And one of the reasons for this talk, right? And I'm pretty sure a lot of you, if I'm not mistaken, have probably encountered or made use of AI, right? I think it's a very hard thing to ignore in this day and age, right? But with the use of AI, we've ideally found ourselves in a position where a lot of us are moving at a pace that, we are not at the same time able to comprehend what it is that we're making use of, and the powers or limitations of the tools that we're actually making use of. And ideally, this talk basically wants to touch on some of those things that we all need to understand when you're actually making use of AI, especially when you're making use of it as a pair programmer, basically, right? So a lot of you probably might have used your ChatGPT, which is very popular, probably used GitHub Copilot, that's also like a popular one. So ideally, if you're a developer, a lot of us have transitioned away from making use of Stack Overflow, right? Back in the good old days, you'd used to go to Stack Overflow, try search through all the chats to look for, your solution. But nowadays, the world has kind of like shifted quite drastically, You don't even have to leave your IDE just to go search for an answer somewhere else. You just type it there, your AI model will just quickly spit out an answer for you. And that's the world that we find ourselves in. And I think one of the key things that, we struggle with is that with the use of AI, there's new bugs that obviously we start introducing. And with those new bugs that we start introducing, there's a level of understanding that we also need to get to, be able to comprehend, right? And you've probably all encountered this scenario before, right? So this is the big, fierce bug that exists within your code base. And you've probably got into a situation where you're busy coding. While you're busy coding, you come across an error. You're like, okay, maybe let me try to fix this error, right? And your AI model will spit out an answer, give you an answer or fix for that specific issue. And then, great, you move on. But one of the things that you still encounter over the while is that, there's still another error that pops up somewhere in relation to the one that you just fixed, right? But at the same time, your tests have all passed. When you actually inspect and look at the code base, you actually don't see anything wrong. Everything looks clean, everything looks good, well-structured, but nonetheless, something is broken, And that's the cycle that most of us tend to find ourselves in. We fix something, another error pops up. Fix something, another error pops up. And the basis of this talk is on the AI error loop, right? So this is just a basic cycle that we all find ourselves in, where a bug will find itself within your system, right? Your AI model decides to suggest a fix for it, and you as the developer decide that, what, this is good enough. Let me accept this perfect suggestion that it just gave me. And then once you accept that suggestion that the AI model gave you, it then obviously forms part of your overall context, right, moving forward. And what then happens is that your AI model now starts to, I guess, reinforce, that specific context as now, your assumption going forward, right? And it tries to now thrive on just ensuring consistency rather than correctness, right? And the key takeaway, I guess, that we all need to be cognizant of is that AI error loops essentially, are just a cycle of feedback, between the developer and the AI model, right? And accepted outputs at the end of the day end up becoming your future inputs. I'll get to that. And most of these AI models, what they end up tending to do is that they tend to now strive for consistency in order to just stabilize, your application, just so that unit test can just pass. That's all it's trying to do, right? Just so you can compile, move on. That's all it's trying to do. But when you start incorporating or allowing these contexts to form part of your overall, I guess, context engineering context within your model, these bugs essentially end up, manifesting into probably by the time you're done with your entire project, within a few days, you've actually lost count or you've lost track of the intent of what you're actually trying to solve for, right? And all you're basically working off is false assumptions that your AI model, had basically put part of your, I guess, your context within that specific context window, right? So why these bugs still slip through, right? Another reason why these bugs still slip through is because the underlying assumption still survives, right? You find yourselves in instances where, your AI model in this specific instance just wants to ensure that, the compiler succeeds, there's no runtime issues, and that your errors disappear, right? And the reason the errors exist in the first place is often not because, it's a cycle of revisited issues. It's that the assumptions that are caused, end up failing at a point where ideally you want to ensure that, and I'll get to how we actually fix that. But the reason why they actually fail is because there's no source of truth, right? There's no, I guess, anchor that can ensure that your AI model always references, one source of truth. And we'll get to how that source of truth actually happens, right? So it is quite important in this instance that, your AI model reasons with truth and not without truth, right? So the reason why most AI models don't necessarily, I guess, have a good view or perspective of what it is that you're trying to solve for is because they have no view of the running system, right? So the only context that they essentially have is just your code base and whatever it is that you're exposing it to or the prompts that you're, I guess, feeding it. But they actually have no good understanding of what your business case is, how it's actually used within production, how, users interact with it, right? So it doesn't have that source of truth as to what's the actual intent of what it is that I'm trying to solve for, right? And it can't, essentially the model itself, when it reasons without any grounds of truth, it can't observe production behavior like I just mentioned. It can't see real user and business outcomes. And the problem in itself isn't the model reasoning poorly, but the problem is that, we expect that the reason, that it reasons with information that it doesn't have exposure to, right? And models that don't have a lack of access to that grounded truth end up venturing off into, I guess, the unknown, right? They end up spitting stuff that you yourself don't know why it would give you this, right? And in this instance, what it ends up leading to is that context drift that I'm talking about, right? And I'll get to context drifts and context engineering as we proceed, right? So obviously, once you've got an understanding of the fact that you need to ground, your AI models to one source of truth, you then obviously want to ask yourself the next question, how does our workflow accidentally turn context into a liability, right? And ultimately, that's what happens when, the information that you're feeding it is incorrect or is outside that specific context window, it ends up becoming a liability, right? And ultimately, that then leads to some sort of context drift, right? So this is the bare essence of what the context drift is all about, all right? So what happens? It starts off with a small fix, right? And something looks genuinely reasonable to accept. You accept it, you move forward. That fix becomes the example for the AI's reuse or reasoning going forward. Then the tests themselves quietly encoded the assumptions behind it, right? And comments confidently explain behavior that was never explicitly agreed on, right? So how sometimes when you're busy working with an AI model, it will give you something, you'll say, good. Just that confirmation of saying, this is good. And then it takes that as, okay, this is what I need to continue with. Forms part of the context, right? So that slight confirmation then forms part of your overall context, right? And then eventually the same bug creeps back up, and just wearing a different, piece of clothing is just, I guess, shaded differently, right? But over time, the system doesn't stop reflecting intent, right? It starts reflecting history, right? And that's ideally what the basis of the talk is going to be about moving forward. So we're going to be talking about intent, which is obviously based and grounded on context. And from there on, we'll basically be able to see, how we can break out of that, right? How you can set a course towards, what you actually intend your system to be used for, right? And this is just a simple example of, you working on a piece of code, you get a null pointer exception, and then, the suggested fix from the AI model is just to wrap it with some sort of condition to say, if not now, then proceed with whatever it is that you need to proceed with, right? This, fine, is perfect. Your compiler will work as expected, no runtime errors, your test will still pass. But the issue in this case is that, is this actually a valid business state, right? Should orders ever be null in your specific business case, right? So it doesn't actually test or have an understanding of that specific business case. And because this specific understanding for it ends up forming part of your context window, what ends up happening is that the symptom in itself was removed, right? So you've removed what the symptom was, and the assumption, however, has not changed, right? It still presumes that this is the correct course to follow, and this is how we should proceed going forward. And the accepted fixes in this case become future context. And the interesting part here isn't the code in itself. It's the fact that nothing in our workflow forces us to ask better questions, right? So in this instance, what we're just trying to solve for is just, okay, I just want this thing to work, and I move on, right? And that's how we start moving then into context engineering. And context engineering, based on what Gartner says. So I have a belief that if your presentation doesn't have anything Gartner related, it's not fully complete. So this is what Gartner says about context engineering, right? And we've slowly moved away from prompt engineering, and the basis of that statement is because you could essentially ask ChatGPT to give you the perfect prompt if you really want to, right? And we've gone now to the point where we want to better understand context, right? And this is where the world is slowly moving to, and especially when you're making use of AI models as your pair programmer. Ideally, what you want to do is now establish a firm foundation in the context that you provided, right? And what do I actually mean when I'm saying context, right? If you take a step back and try to understand what context is, this is something that comes from Anthropic, and it basically just explains prompt engineering and context engineering, right? And like you can see, when With prompt engineering, obviously you just provided a prompt and then it spits out an answer that would be likely correct. But now with context engineering, it takes into account every single thing that contributes towards you having an answer. So if you think about it in this case, if you're using your AI as a pair programmer, context in this case would be any sort of file that you feed your AI model, any external references that you feed your AI model, that forms part of your context. So for it to actually give you an answer, some sort of answer, it needs to actually have a good understanding and access to all that information that you just fed it, right? So it's no longer just basing it off, a prompt and, based on what it's been trained for and what it knows. It's now basing it off, what you have. So in a typical engineering team, in this example, there's obviously like a lot of things that go into engineering teams, right? So in my own personal experience, obviously, any engineering team should have a good set of coding practices, right? So I know that as a team, this is how we do our pull requests, right? So this is all the standards that you should have. And when you're coding, this is how your variables should be named. All those standards are things that actually feed into your context, right? And ideally, what you want to do is that you want to ensure that your AI model has access to all those things, Otherwise, if it doesn't have access to those things and it doesn't have an idea of what it is that you're trying to solve for and what the intent is, it then obviously then generates whatever it sees fit, right? And because it ends up generating what it sees fit, then that's where you start seeing the gap, the misalignment between the responses that you get and obviously what you're trying to solve for. So in this case, context engineering has to do with everything, like I said, that you feed it. But if you can see there's something called a context window. It's not just about feeding it a bunch of information all at once. It's about feeding it the right amount of information at the right time, right? So that's basically the basis of it. So it doesn't help me asking you for an answer to a specific question that has to do with calculus maybe. And while I'm looking for a specific calculus answer, I'm busy feeding you books that have to do with physics, aerodynamics, all this other stuff, that have no, contribution towards the outcome that I'm looking for. So obviously, the only correct information or, that you would need in order for you to provide an answer would be stuff that's related to calculus, right? So feed it the right information at the right time, and that's ideally what the context window is all about, feeding it what's right at the right time. Cool. So there's a research paper that was done by Chroma a while back. I think this was sometime last year. And with this, they were basically looking into something called context rot, right? And the basis of the paper basically was just to give us an idea or an understanding that there is some sort of direct correlation between performance and the amount of information that you feed your AI model, right? So obviously, if you're going to be feeding it a whole bunch of stuff, you'll see some sort of degradation in terms of performance. Your performance will slightly, decrease, right? So they put up, the same tests across various AI models. And obviously, as you could see, those performance started to dip a bit, right? But the basis of basically this specific research, right, is that more context does not mean better context, right? I don't know if that makes sense. So me giving you a lot of information doesn't mean that it's good for you. It doesn't mean that it's the best thing for you. So ideally, that's what we are trying to solve for. We are trying to ensure that the context that we're giving you is relevant towards you getting to the output that we seek, right? And, it's also about making sure that we're able to silence the noise around, the information that we're seeking. So part of this research, what they did was they did something called a needle in the haystack, test. So what they basically did in this, so imagine, I don't know, I'm assuming you guys, when you did your English comprehension tests back in high school and primary, that give you like 2-3 pages of an essay for you to read, only for them to ask you one simple question that you now need to go dig through the entire essay just to go find that answer. And that's, if you think about it, that's what AI is all about, what I'm trying to communicate is all about. That there's all this noise around the information that you're looking for, right? But it's important that you just filter out and silence the noise around it just to get to that answer, right? And if you are a developer that's making use of AI models to try to, execute or deliver as efficient as possible, you don't want to give your AI model, a comprehension that is like 5-6 pages. If you know that your answer lies somewhere in the last 2 pages of the last page, just give it what it needs, right? And then from there, you ideally you get what you want. So anyway, context rot. So that is context rot. Giving it a whole bunch of information that leads to, I guess, a degradation in your performance. That's what ends up leading to context rot, right? And it's the thing that we need to understand. It's a gradual thing. It doesn't happen instantaneously. Like you can see, it's not like it just drops immediately from. It's a gradual thing that happens. So we need to keep that in mind when we're actually making use of our AI models in coding, right? That, yes, you might feed it information, it might give you the right answer now, but over a certain period and a certain time frame, that begins to dip, right? And some common context anti-patterns, right? So once you start thinking about context as something that is deliberate and intentional, certain patterns begin to be visible, right? You start seeing certain stuff now, and you start seeing that long chat threads, gets reused because it feels efficient, right? I don't know if you've ever been in a situation where, especially with ChatGPT, where you're writing something, and it keeps on suggesting something that it told you like 5 or 6 chats above, right? And as much as you told it that this is not what I want, that's course corrected, this is exactly what I want, it will somehow still keep on referring to that. And I'll speak to how you break out of that. So that in itself can also manifest within code when you're making use of your, I guess, GitHub Copilot, any sort of AI model within your code base. Ideally, those are some of the things that you end up seeing in your pair programming, assisted models. So one of the key takeaways, right? Reuse without intent accelerates that drift that I was speaking about, that context drift, right? And context quality degrades quietly. It doesn't just happen instantaneously. Then, you then have to, I guess, forget whatever you had in the chat history and then move forward. No, it takes, a progression, right? And the good news is that once you can see these patterns of how, your AI model is giving you, for lack of a better word, junk, you start now understanding that, there's a shift or change that I need to do, right? And that change doesn't come with asking the perfect question, like I mentioned. This is not about prompt engineering. It's about context. Now you start understanding that it's more about what am I doing as the user to make sure that I get the best possible answer for, the problem that I'm trying to solve for, right? And how do we break out of these things, right? So one of the key things that we can do to break out is to reset and narrow your context, right? So start new tasks with a fresh context. So ideally what you don't want to do is that you don't want to make use of, context from like maybe, 5 days ago, or context that's a bit old and not relevant to what you're trying to solve for. You want to make sure that with every single problem or every use case, you want to make use of new context, right? And ideally also what you want to do is that you want to limit examples to what's truly relevant, right? So I know that I do this a lot, when I'm busy maybe working on something, maybe on ChatGPT, Claudia, whatever model that I'm using, I'll ask it a question, why is the sky blue, right? And it will tell me a big, beautiful answer about why the sky is blue. And then somewhere along that answer, I then have another follow-up question. Okay, so why this, right, in relation to what it just spit out? But ideally what happens there, it's now starting to drift into the unknown. It's now start taking an input that is not essentially relevant to maybe me just asking a simple question of why is the sky blue, but it starts now getting into the physics and all that other stuff, right? Depending on the other follow-up questions that I keep on asking it, right? So it's important that we limit those examples to just what's true and relevant to that specific instant, and treat context like working memory, not storage, right? So treat it as though it's something that you would want to remember now, but not something that you would want to store and revisit 5 days later or 2 months later, right? So ideally, you just want to store it as or treat it as working memory and not storage. And one of the key things that I actually wanted to touch on here is that intentionality of what it is that you're doing is quite important, right? And ensuring that you always reset, it's quite important. So when I started being a dev, back then, when you were faced with the problem, you'd ideally take a break, to reset, right? I don't know if you guys do that, but you would take a break, stand up for an hour, take a walk, maybe go play some games, come back, and you'll come back with a fresh perspective, right? And that was the reset that us as humans, would rely on, right? To ensure that we take a different perspective towards the problem that we're trying to solve. But in today's AI world, oftentimes people are relentless in terms of asking your AI model the same question. This doesn't look correct. Give me another answer. This doesn't look correct. Give me another answer. And it just becomes a cycle that is just never ending. But if you actually think about it, you could still apply the same, process that naturally as a developer you'd follow without making use of these tools by just saying, forget everything that I just asked you and forget everything that we've just spoken about. Let's take a step back. Let's start from the beginning. This is the issue that I'm facing. How do we solve it? And you'll start seeing a different turning of events because now you're approaching the issue with a fresh, new mindset, right? Or the AI model is using a fresh, new mindset to address that, right? So that's what I mean by breaking out of the loop. And then the second one is that you should always anchor on some sort of external truth. So have some sort of truth that you can use as an anchor for your model, right? What do I mean by this? So when you are working on a project, it's very unlikely that you would be working on a project that just has one class and one file, right? Chances are you have multiple files, you have, different API schemas that exist within your code base. You have coding standards, like I mentioned earlier on. You have test cases that exist outside of maybe, that specific class, or module. And all of that serves as a source of truth for your AI model, right? And you can see this when you make use of your GitHub Copilot instructions, right? So there's like a markdown file that basically you use to stipulate what your source of truth is, right? So, and basically this is what your AI model should now be referring to every single time it comes up with any sort of suggestion. Ensure that you stick to this, right? Do not venture off and start hallucinating and tell me about stuff that's not relevant for me, but stick to what the truth is, right? And this file, I'm pretty sure you can do the same thing with almost any AI model that you can, incorporate within your IDE. Most of them would have some sort of instructions MD file, right? So this is for GitHub Copilot, but as you can see there, what I'm telling it is that this is the purpose, this is the intent of what we are trying to solve for, right? And these are the domain rules, these are the, the boundaries that you need to operate in. Do not introduce new dependencies across bounded context. So this is basically me just telling it what not to do, what to stick to, right? And this is how you anchor it to some sort of truth, right? That outside of, our conversation, every single time you think of an answer, refer to this as something to rely on, right? And then the third one for you to break out of the error loop is human in the a human in the loop is actually quite critical to any usage of AI, right? And what I mean by that is that, and this is what I always say when I talk about AI models, is that it's all good and well to make use of AI, but you should always trust it, yet verify it, right? And that verify part is the most critical thing, right? That even if you're gonna make use of an answer, you must still go check if that answer is relevant. You know, I've used AI models in instances where maybe I'm working on some sort of research and it'll blatantly, without any shame, give me, you know, a reference to something that doesn't exist. And that's the problem with AI, that if you don't validate that, you know, you could find yourself making reference to a research paper that no one has ever heard of, no one has written. You find that even the human that it assumes wrote that doesn't even exist. So it's quite important that we enforce some sort of human judgment in our interaction and usage with AI models, right? So that's quite critical. And the thing about, and that's the thing about us humans and AI models, right? Is that we have a source of judgment that's not ambiguous, that's not, I guess, cryptic. If you know what it is that you're looking for and what the understanding of what it is that you're looking for, you yourself can only know that, right? And it's up to you then to interpret that and make sure that whatever your AI model spits out, you know, correlates with exactly that understanding, right? And that's the key thing that I'm trying to communicate with this one, that judgment at the end of the day, you know, breaks this loop that AI can't, right? And humans close that gap between consistency and intent, where an AI model, its key focus is just being consistent in giving you an answer. But intent at the end of the day is the lack, right? And once you put all these three breakers together, the role of AI in the team starts to look different, right? So once you start thinking about it then, you start then thinking of AI, and no offense to junior developers, but you start thinking of AI as a junior developer. I remember my first time being a dev, right? And the very first time I broke something in production, which was an honest mistake. I remember very well that I was given a piece of work. Okay, you go work on this feature. And somewhere along the way, I saw that dreaded squiggly red line, right? And I was like, actually, this specific error is causing me issues. Let me just delete this. Then I deleted that piece of line, right? And fine, deleted it, fixed up my unit tests. Everything was working perfect. Checked in my code for review. You know, it got approved, got merged into the main branch, got deployed. And that's the thing, you know. These types of disasters always happen when you have to deploy to production. So it happened that, you know, that specific merger was being deployed the next day. So checked it in, all good and well, walked in the next day to be called by the senior architect to his cubicle. He's like, come here, why did you commit this? Why did you remove this piece of line? I'm like, well, I guess I wanted the test to pass, you know, and that was my reasoning back then. Then I actually just wanted to move forward, you know. It was an issue for me, so I just removed it, you know. And to me, I was like, you can't just go about deleting stuff, you know. That's not how it works. And that is the intent that you should always approach or make use of AI, right? That itself, it doesn't have an understanding of, you know, what it is that you're trying to solve for. It doesn't have an understanding of what the business case is, what the use case is at that point in time. And it's important that when we make use of these AI models, we make use of them literally as though it's a baby, right? You should validate that, okay, I get the answer that you're really trying to help me. I do understand this, but this does not solve the problem that I'm trying to go for, right? And it's quite important that, you know, we are able to set these boundaries when we're working with our AI models. And one of the key takeaways that I actually want you guys to be aware of, right, is when we talk about basically just breaking the AI error loops, right, there's a number of things that I wanted us to think of, right? The first thing is that context outlives prompts, right? And I think I made that clear in terms of the explanation around context engineering and the fact that, what we accept today becomes tomorrow's baseline, right? So if you're going to accept a specific, suggestion from an AI model, that becomes context for future responses that you're going to get, right? And context then ends up accumulating long after the prompt is long forgotten, right? And that then feeds into future responses. The second one is that intent must be enforced, not inferred, right? So if intent is not explicitly encoded, in your, constraints, in your tests or validation, then the system will invent its own, literally. And I think we've seen this quite a lot in examples where it'll just start hallucinating, giving you stuff that's not relevant. And actually just on this, I think there was a case or an article that came out where one of the, I don't know if it was ChatGPT or what, but they're basically getting to a point now where they're able to tell you that actually I do not know this answer, or maybe you need to validate it. And that's a step in the good in the correct direction, right? Because ideally you want to get to a point where our AI models are able to, have some sort of restraint in not confidently giving you the wrong answer, So this is what we need to ensure, that intent must be enforced and not inferred, right? And then the fourth one that I want to touch on is that agreement is not correctness. And I think that's quite critical. And most of the time, consistency can emerge around the wrong idea, right? And confidence and repetition do not equal truth. So in most cases, we find ourselves in, and I think I spoke about this, where you just agree to something saying, well, this is good. When it gives you an answer, it takes that and ultimately just wants to maintain that level of consistency in terms of, ensuring that, it just solves around, that agreed upon, response. And then ultimately what happens is that with that specific repetition, that now becomes the foundation of something that, you shouldn't be moving forward with, right? And then the fourth one is the judgment is the real loop breaker, right? And like I said, this one is quite big because use your AI models, trust your AI models, but always verify, the stuff that it gives you. And with this one, the tools that we use, especially as developers in our IDEs, when we're coding or when we want some sort of code review, assistance from our AI models, these tools essentially help us in terms of being productive, being efficient. They reinforce these patterns, but only humans can interrupt them, right? Only humans can break that barrier or chain between what is correct in terms of intent and what is correct in terms of business case. And AI models, all that they see as what you give them. So that's basically the basis of all this stuff that I just told you. And I guess just the punch to close it all off is that AI doesn't fail loudly. It fails by agreeing. And that's the danger that you need to be aware of. That oftentimes, I don't know if you've ever encountered a stranger walking down the road, you ask for directions and they confidently, with a smile on their face, give you the wrong directions. While you're walking, you find that you're lost. So that's the thing about AI models, is that you should treat it like that it can confidently give you the wrong answer. And you need to be aware and cognizant of the fact that everything that it gives you needs to be scrutinized to a certain extent, right? And that is me. Thank you so much. This is where you can connect with me on LinkedIn. So just hit me up on LinkedIn. And I don't know if there's any questions. I think I still have a bit of time. We can maybe 1 or 2 questions, feel free. But thank you so much for the talk. I hope it was insightful. And I hope you use your AI models wisely. Thank you, guys.